lot of work.
It's a lot of work, that's for sure. But I'm glad you think that, Dana. Yeah, I'm glad. But it does mean that I can go back to my day-to-day routine, not have to prepare stuff for you guys every day. I'll still be around though. I might come to your study sessions over the weekend and stuff like that. And you're always welcome to message me on Slack too if you want. But so today, day number 10, we're going to talk about stack traces and debugging to start with. And then I've had a couple solicitations from the class throughout the day and before the class about other things we should talk about. So we're going to start here. And we're going to see how we go from here. And the goal at the end of the class, after we get through all this stuff, is to hopefully finish up this New York Times exercises. Because like all you guys are very close. Like you've done all the module 5 stuff. It's just getting all the module 4 and before stuff done after that, pretty much. So it's making great progress. Okay, stack trace. So a stack trace is one of these things. You've seen these things before. All you guys have seen these. You come to me with problems with these things. And it's a way to figure out where in the program, where the program has gone prior to an error occurring. We're going to go through a little demonstration to explain kind of like what all this stuff means. But typically you see at the very beginning, you see this sort of error line. And that's usually what you guys cling to start with. That's a great thing to look at to start with. This tells you the thing that went wrong. Then below it, you have all these different what are called stack frames that tell you where the program was before. So let me, oh, okay. Well, we're actually talking about stacks first. I forgot about that. So a stack trace comes from a thing called a stack. And a stack, just like in a programming language, it's like a data structure that's used, just like an array or an object. It's a way you can store data in a program. Now, it's in the same sort of family as like queues, linked lists, trees, objects, arrays. And stacks have two sort of core operations. Think of them like an array, where you can do two things. You can push items onto the end, and you can pop items off the end. Those are the only two things you can do. You can't do things like get the first item, or like remove an item in the middle, or like modify an item. You can just add things at the end and pop things off the end. So it's always you're always doing it from the far end.
So push to the end or
Yes, off of the end. And we're going to do this in a second. These sorts of data structures are usually called last in, first out, or LIFO. There we go with the acronyms for today. As opposed, there are also things called FIFO, first in, first out. But last in, first out, because if you put something in at the very beginning, and then you add more stuff to the end, that thing that you put in at the very beginning is going to be the last thing to come out if you just start like popping off the end of the data structure. So if like I add a thing, and that's the first thing, add a second thing, add a third thing, then I remove this thing, and remove the first thing. That first thing was the first thing in, it was the last thing to come out. That's opposed to other sort of data structures where it ends up being a little different because you have more operations you can use. Does that make sense? Okay, cool. And in JavaScript, there are some libraries which will implement a stack for you. But it turns out you can use arrays too. If you just use only the push and pop methods on arrays, you can do this sort of thing. So I'm guessing you guys have probably been exposed to these methods, but push adds an item at the end of an array, pop removes an item from the end of the array. Same sort of thing we were talking about here. Okay. So here's an example of a stack. I have a bunch of different fruits. So I'm going to start off, I have one item in my stack. And then I'm going to push an item onto the end of the stack. I'm going to add orange onto the end. And I'm going to add apple onto the end. And notice how I'm adding things to the top. Not adding things to the bottom, not adding things to the middle. It's stacking up, like a stack of paper or a stack of cards. I'm going to add grape. And then if I want to pop things off the end, I will pop things off the far end. I won't touch things at the bottom. So I can go all the way back down again. So that's a stack. So let's try out some stacks. You guys are welcome to follow along with this. Let's. Okay. I also realized I didn't grab my microphone. Okay, cool. Okay. So I'm going to create a new variable, and I'm going to call it stack. I'm going to set it equal to an array. So it should look pretty familiar. Now I'm going to add something to the end of the stack. So I'm going to push 1 onto the end of the stack. Now if I take a look at stack, I've got 1. I mean, this shouldn't be all that astonishing, I don't think. I can add something to the end. I get 2. Pop something off the end. Now, I can push things, like I don't have to empty it out to push things on. I can push things on in the middle. So I could push something on here. I could push 3 in. And then I want to have 1, 3, because I already popped off 2. And I can clear out that stack by popping twice off of it. So that. And then my stack is empty. So that's stacks. Stacks are a very common data structure. And you might be thinking, why is this relevant, Ryan? Well, I mentioned at the very beginning stack traces. And the reason why I wanted to talk about stacks is because unless you understand what a stack is, understanding what a stack trace is a little bit harder to grasp, at least in my opinion. So that makes sense to everybody? Yeah.
So like so you use an array to represent a stack. So like a stack is a data structure. So are all data structures just like a method of doing things?
You could think of it like that. So the reason why data structures kind of existed, well, I don't want to say existed. The reason why often you'll hear of lots of different data structures, because way back in the day, we didn't have high-level languages like JavaScript or Python or Ruby or something like that. And the way all these data structures were built were like manually by like twiddling bits at like a low level. And because of this, there were different sorts of ways you could structure the way these things worked. So you could optimize for different operations. So for example, a stack, if you were to build a stack, like not in JavaScript you use an array, like build a stack in like C or some lower level language, what you would do is you'd build it such that when you push things and pop things off, those are really fast. If you want to do something like search through the whole stack for something, that would take a long time. And the reason why you build it that way is because you optimize the structure for the things that it's meant to do. Now, I'm using an array because it's easy and you guys can do it. But there are libraries in JavaScript you can download. Debating using one, but decided it would be too much trouble. That actually do implement these stack operations. They don't use an array inside of it. They implement it the same way you would in C. And they optimize for like pushing and popping. And like everything else, they don't really implement because it's slow or it's unruly. Does that make sense? Cool. OK. So stacks. Now, the stack. We're getting a little more official here. Most programming languages, they actually use a stack behind the scenes to keep track of where you currently are in the program. And when I used that word stack frame before, a new stack frame or an entry, one of these like entries in the stack, is created whenever you call a function. And I'll explain that in a moment. But OK, yeah, here we go. So I'm going to walk through this program. So maybe to start with, let's walk through it by hand before I run through this and use it with the stack. But there's just so everyone knows what it does. So we have a bunch of different functions. We define foo, bar, and baz. I'm going to call baz, which is going to go up here. It's going to go inside of baz. It's going to call bar with 5. It's going to go up here. It's going to call foo, and then it's going to go up here. And then it's going to log something out. And it's going to return from foo, return from bar, return from baz, and go all the way out of the program. Should be pretty self-explanatory to everybody here, I'd guess. That make sense?
You started from the bottom to the top.
Yeah. So if you were to start at the top, it would define this function and then skip down here, define this function, skip down here, define this function, and then it would actually start running the code because at the very bottom is when you call the first function. Yeah. So I'm going to do that again basically, but so foo, bar, baz. So the program, this is like where the program currently is as it's running. So we start there, we go to bar, we go to baz, and then we get down to the very bottom where we're calling baz. What happens then is when I call a function, it adds an item onto the end of that stack. It's going to add baz at the end. And now we're inside of the function baz, and we're going to go inside and we're going to run that function. And when we run that function, now we're going to come across another function, bar. So OK, I'm going to call bar, and when I call bar, it's going to, just as before, add another item to the end of that stack. And we're going to do the same thing here, foo. You can kind of see the pattern here. As you get deeper into your program, as you call more and more functions, this stack grows and grows and grows in size. So I'm going to call foo. I'm going to go up here. And then I'm going to get to console.log. And this is where my log would happen. And then as I then exit out of the program, as I leave a function and go back, it's going to pop that item off the end of the stack because it's left that function. So in effect, this stack here acts as a way that you can see, if you want to get the current function you're in, you just get the top item off of the stack. Take a look at that. If you want to see where you've been throughout the whole program, in other words, all the function calls you've taken to get until where you are currently, you can just look at this whole stack. And like here, in order to get to this line here, what we did, we started at the beginning, then we called bats, and then we called bar, and now that got us in here. So it kind of serves as a way you can like understand how you can follow the flow of your program from beginning up until where you currently are. So I'm just going to finish this out. So I get to the bottom of bar, it pops it off. The bottom of bats, pops it off. Get to the bottom there, we're done. So that makes sense? OK, cool. Now, we're going to do the same thing. I'm kind of jumping back into the middle here. So imagine we went through all this, and we're back to this line. So we have our stack repopulated here. But now an error is going to happen. Something is going to go wrong inside of this function. And when something goes wrong, this is where the whole Stacktrace thing comes in. So when an error happens in your program, JavaScript's going to pause. It's going to halt. It's going to basically figure out what sort of error happened. And it's going to store that somewhere. And then what it's going to do is it's going to take a look at the stack. And it's going to get the error, cannot read property exist if undefined. In this case, just whatever error it is. And it's going to take this stack that we put together, and it's going to turn that into a bunch of rows underneath of your error. And that's a stack trace. So in effect, what this lets you do is it lets you say, OK, so my program, I started at bats. I then ended up now into bar, and then now ended up into foo. And then inside of foo, this error happened. What do you guys think about this? Any thoughts? I'm seeing some.
So it's basically saying we're mistaking the foo and the bar and bats. Then I go back to the code.
Yeah, this.
Yeah, because there's where you use foo. OK.
Exactly. So in order for this error to happen, I had to call bats, and then I had to call bar, and then call foo. So I had to call bats, call bar, call foo. So that's like tracing your way through the program. And now you see all that stuff. You'll also get a bunch of other little bits of information. So you'll get the exact line and column of where the error occurred. You guys probably have run into this before, I'd imagine. You also get the exact line and column of each invocation of that function as you go like through that stack. So for example, like the Baz call that got you into there, that exited or that created this stack frame is located at row 3, column 1 in your code. And the bar one is located at 5.1, and same sort of thing. And you got your error name and you got the function name. But in general, that's and we're going to do a little exercise here in a second. But this is the sort of way you'd read a stack trace. You can look at this thing. You can figure out where your program has gone, and then you can take a look at this. You can figure out what exactly has gone wrong. Do you hear?
I didn't know there were columns.
There are.
Yeah, I don't.
Yeah. They're not as useful as you'd think often, because sometimes you'll run into cases where, like, because of the tools you're using, they'll sometimes screw up the columns. At least I've run into that sometimes. But I usually go to the row, and occasionally I'll use the column for something. Dana?
And just adding to what he was just saying, is it easier to see, because I know we've been using console log, but I know there's also like console table. I saw that, so does that help to like visual? Because I know that it helped me doing previous exercises. So I needed to see what things were, and I didn't know that it existed. So that's when I realized that really.
Oh, interesting. Yeah. I think what Jquery was talking about was more about the columns in the source code itself. Like there's a line number and a column number for like a specific location where an error happened. But console table is really cool.
Yeah.
I haven't done a ton with it, but every time I've used it, it's made like a really nice little visualization for me.
So the column number effectively just like the character position
Yes.
on that line.
Yes. Okay, so everybody good?
Yeah.
Okay. So how to read a stack trace. So start by reading the error message. That's what you guys typically have done. And then next, the kind of thing you usually do is you click over here and you go to the line at which it happened at. So this in Chrome, it'll actually take all these sorts of things. Well, it's not going to here, but in Chrome, it'll usually make all those line numbers, where all the errors happen, clickable. So you can click on them. It'll bring you to the source code in the DevTools, and it'll show you exactly where the error happened. It'll show you each of these stack frames if you want. So you could, if you have an error and you want to trace the program from beginning to end, you could start at the very bottom of your stack trace, click on the first one, look around, and go back to your stack trace, click on the second one, look around, and keep going up the stack trace until you get to the top, and then you click on the one on the right, and you see exactly where the error happened. So you can effectively trace the program through its whole flow. And if you need more context, you can click through the stack frames. Now, when you do that, it will open it up in DevTools, and you can look around where that line is as well. So often, what will happen with me is I'll click on a line in the stack. I'll click on a stack frame and go to somewhere in the code. And I won't be looking at that line. I'll be looking around it. I'll be looking at more the context of where that call happened. I think I have OK, I don't have a slide on that. So there's often you'll discover that when you have errors that are not super obvious, the reason what usually causes them, or what often can cause them, is not your code in particular. It's other code that ran and did something unexpected, but still OK, but left your program in a weird state that now this other code that's being run is being run in that weird state. And that's a great case where stack frames are handy. Because if your code is being left in a weird state earlier on in the program, you can go to a stack frame, take a look around, and discover, oh, this code here, this code's syntactically correct. This code maybe runs and produces a result, but the result's wrong. It's like if you were performing an average, and instead of adding all the numbers, you subtracted all the numbers, and you divided by the number at the very end. If you did, let's say you did that in a different function, it was in an earlier stack frame. The only way you'd be able to figure that out is either looking at the source code and analyzing it, but barring that, let's say this is a more complicated thing, you'd have to go back into the stack frame, and you could click on an older stack frame and notice, oh, wait, that's a minus, that should be a plus, and change it. But if you just click up here on this error message, you're not going to find that. You're only going to see like the surface level, what actually caused the program to halt. You're not going to necessarily see the problem. Does that make sense?
Yeah, except exactly what do you mean by the stack frame? I mean, I know you were talking about
Each of these
actual
entries.
stack.
Yeah, so stack frame is one of these things.
Oh, okay.
Or each of these lines here.
Right.
Another thing about stack traces, there are often bad stack traces. Stack traces are the sort of thing that for many, many years and in many different programming languages, they were considered a luxury, the sort of thing that if you were lucky, you got them. And you just kind of had to, Doug, you're laughing over there, and you totally what I mean. You just kind of had to suffer without them and kind of just work through it in your brain. That's really hard. So these days, pretty much every language worth its salt gives you stack traces. And if it doesn't, there's either a historical reason why or you shouldn't use the language. But not all situations, even something like JavaScript, which is a pretty good language for stack traces, will give you good stack traces. The two that I want to touch on, in the JavaScript console, you're not going to get good stack traces. Why is that? Well, the way the JavaScript console actually works behind the scenes is imagine Chrome created, or whatever browser you're using, created a file in memory, a JavaScript file like in the program's memory. And whenever you type the line into the JavaScript console, it then took that line and added it to the end of that file. And then after that, it ran that whole file and computed all the results, and then showed those results on the screen. So imagine that's how it works. But because it has this file in memory, it's not actually a file on disk. So often that can lead to some weirdness behavior in how Chrome does things. What you'll often see in that case is something that looks like this. You'll see anonymous : these line numbers. And if you click on it, what it will do in Chrome is it'll take you to that file, and it'll show you the line of the file that it went wrong on. But what will often happen also is because all that stuff is in like this in-memory file, if you have you want to get a bunch of stack frames, it'll cut them off after a while because Chrome just does stuff in a weird way. But in any case, the JavaScript console will often give you bad stack traces for not incredibly simple things. The other one, which is a little bit more concrete, the functions or processes with asynchronous behavior. Now, imagine you're running a fetch call, and you make that fetch call, and then you have the promise you attach to it, and you have the function inside of it, you do something when the fetch call completes. When that fetch call completes, and let's say when that fetch call completes, you like log something out, and somehow you cause an error to happen. The way JavaScript works, and I'm not going to get into it right now because it would probably turn into a rest of the class sort of thing, and I'd have to do some research too. But the way it works, effectively, whenever one of these sort of asynchronous events occurs, whenever like a fetch happens or like a set timeout or any of these sort of other asynchronous things you guys have learned about so far happens, the stack trace is kind of, oh, someone said something. No?
Someone laughing.
Oh, okay, sorry. I have the ears going. Effectively, whenever you have one of those asynchronous sort of function calls, what's going to happen is your stack trace is going to get interrupted. And what you're going to see is the stack trace from the point of the last asynchronous call until your error. So if you have, let's say I have an error that happens in a set timeout. Let's see if I can do a demo of this. This might be kind of fun though. I do something like set timeout. I'm going to write a set timeout. I'm going to run it after a second. Inside of here, I'm going to do something like a function foo, and then I'm going to throw an error. This is an error inside of foo. I'm going to call foo. So when I run this, what this should do is after a second, this function here will be run asynchronously. And then after that happens, we're going to call the function foo synchronously. So at this point, this function on the outside is run asynchronously. But once you're inside of this, all the stuff you're doing is synchronous. So I'm going to run this foo function synchronously. It's going to run up here, and it's going to throw an error. I think what we're going to see is a stack trace that does that stops at the end of it is at the foo call. Let's see. I'm not sure about this. Okay, so it ends at set timeout, but like it doesn't have anything before that. Like that's all you see. Maybe let me try one other thing too, just to make it even more
I
clear.
was getting async errors with like promises, like I was putting something in the wrong spot and it was telling me like, I don't know exactly how it's worded, but it's like async something with the prompt, like it was waiting for the promise. Like I put it inside the wrong spot, like so it wasn't.
Yeah.
Do you know what I'm talking about? Yeah.
Oh,
Yeah.
okay. Yeah. Yeah, I think I know what you're talking about. Let's chat afterwards. I need to see exactly what your code looks like.
It was just because I was putting something where it wasn't supposed to be.
Okay.
Or, yeah.
Okay. So I'm going to make a function bar here. I'll put all this in bar. I'm going to call bar. If this does what I think. Yeah. So if you notice here, bar is a function. I'm calling bar down here, and that kicks off a set timeout. This is happening synchronously. Like if I get rid of the set timeout here, if I get rid of the set timeout here, and I just have like this. So I would call bar, which would then call foo, which would then throw this error. If I do this, and I call bar, we're going to see both foo and bar, because what happened here is that both of those happen synchronously. Where now, if I have the set timeout in there, we're only going to see foo because foo is the bit that happens synchronously after the asynchronous set timeout happened. So if you have an asynchronous event, effectively all the stack trace before that is lost. You can't get access to that. Does that make sense?
Mhm.
Okay. No. Okay. Let's chat afterwards, Dana, then, because I think I might be able to explain this better to you in one-on-one. Anybody else have any issues with this? Because if other people have issues, I'll go some more into it.
Just explain the difference between synchronous and asynchronous.
Okay.
That might help.
Yeah, okay, definitely. So in JavaScript, there are two different ways a function can be invoked. Synchronously is probably like you've pretty much done it for most of your time in JavaScript, where you just call a function. Yeah, so if I had like a function like baz, I log out something inside of it. I call it like that. I'm calling it synchronously. So when I call baz, it immediately jumps inside of here, and then it runs the code inside of the function. Now, something like fetch or set timeout, you are, so yeah, you are calling it asynchronously. And what that means, I'm going to put a console.log test in here again, so it does the same thing.
So fetch is using fetch is an example of asynchronous.
Yes. I think the two real asynchronous things you guys have talked about so far are like set timeout or set interval or something like that, and fetch. Maybe more, but those are the two that I think you guys have talked about. Something asynchronous, what that's going to do is it's not going to call the function immediately.
Right.
What it's going to do is it's going to schedule that function to be called later on. And because it's being scheduled to be called later on. Like if I run set timeout here, put a 2000, make it even more obvious. But I run this, I don't see test, and now I see test because that's being scheduled to happen later on. The difference here being when it's scheduled to happen later on, effectively you can think about it like you're taking that function and you're kind of storing it away for later, and you're continuing to run your code. And then once that function, like its time is up, or like it's time to run it, the JavaScript then jumps over to that function and runs it.
Okay, and so the asynchronous method, where it concerns the stack traces, what were you saying about that?
So because it's storing that function later on, and it's jumping to it later.
Right.
By the time it jumps to it later, it's already left the context of where it was invoked originally.
Oh.
And because you've lost that stack trace before, now when you jump back to it before, it doesn't really have a stack trace to start with.
Got it. Okay.
Yeah.
Got it.
Okay. Cool. Yeah. So it's yeah. Just some tips on stack traces, I guess. So that's what I think all I had on stack traces. Let's see. Did I write exercises? I don't think I did write exercises for this. Okay. Yeah, I don't think I wrote exercises for this, but I think really the exercises are just you guys being able to use it for debugging things like the New York Times assignment. But in general, any questions you guys have about stack traces? Like, does this hopefully this helps you be able to read some of those error messages a little bit better. Okay. So I had a couple more things that people had asked me to talk about today. And the first one, I think I'm going to do this one first because it's just at the front of my mind. Caitlin was asking me, she's running into this issue where she sees through a screen printed this awesome phrase here. I bet she isn't the only one who's seen this. No.
Oh.
This, oh, not that. This. Have any of you guys run into that before? Yep. Okay. What is object? Well. So. No, it's not bad. It's actually it's not too bad. So I'm going to make an object, and I'm going to do let's see. So are you guys familiar? So you guys are familiar with prototypes on objects. Are you guys familiar with the toString method?
I don't think we learned that.
Okay.
Is it because it can't print an object, like it can't make it readable, so you have to like
Yeah, kinda.
change it into something that
Yeah, kinda. Let me get through this though. So I'm going to do something like array. If you type like any sort of thing dot prototype, so get the prototype of like a class. Almost everything in JavaScript, well, I think actually every object has a toString method on it. So arrays do, objects do, one more, regex, they all do. So this toString method, when it's called, is a way that JavaScript can take any sort of data type and convert it into a string easily. And why is this needed? Well, there are situations, and we'll talk about them in a second, where you might want to take any sort of data type and convert it into a string. But let me show you what this does when I call it on this. Well, actually, before I do it on the object, let me do it on a number. I'm going to do var a is equal to 1 and call a toString, I get 1. So that makes sense. It's a string version of that thing. Let me do it on a string. Pretty much, it's the same thing. So that makes sense. Let me do it on an array. Empty string. It's kind of weird. Okay, let's try it on an object now. Object. Whoa. So let me do it on one more thing, and this might maybe help a little bit. Let me try new regex. Oh, okay, that didn't help at all. I guess regexes do something special. But object. So whenever you take an object and you can coerce it into a string, JavaScript is forced to turn it into a string. It turns it into this thing, object. And the reason why is, you guys I'm guessing you guys have learned about how in JavaScript at the prototype root, there's, we'll say at the prototype root, there's the class object. Like a bunch of things in JavaScript inherit from object. Like, for example,
I got that.
like,
native code.
oh yeah, that's a little bit different. We can talk about that afterwards if you want. But like something like regexes are objects, or numbers are objects, or lots of other things are objects. And it's kind of like if you talk about object-oriented programming, it's like the base class that everything inherits from. Are you guys familiar with that term, base class? No? Okay. It's like if you were to take the prototype of everything, well, I don't want to say everything, but most things in JavaScript, the prototype of most things in JavaScript have everything that exists in an object. They have all the methods that are on an object, including like the curly brace things you make as objects. Those are a type of object, but they're a type of object just as much as like a regex is an object, or other things in JavaScript are an object as well. It's just like the curly brace object is like a type of object, and often they're called plain old JavaScript objects if people want to be pedantic. But on the object, there is this method toString that's implemented that will take anything and convert it into a string. And if you run this on a plain old JavaScript object, or like an object you have with curly braces, it'll output object. Now, you guys haven't run toString, so you're probably thinking, well, why am I getting this? Like, where is that coming from? Well, there are lots of situations in JavaScript where JavaScript will coerce an object to a string. Have you guys run into the notion of like object coercion yet? Okay, and that, or type coercion, yeah.
Does that have to do with like the equal operator, like where you have two equal operators, kind of like?
Yeah, that's a case where it happens. Yeah, definitely, where you have like something like true is equal to 1, that sort of thing. It kind of coerces those both to booleans and compares it. So it'll coerce 1 into true because it's a truthy variable. You've heard that word truthy before. Mm-hmm. Yeah, okay. So it's kind of similar to that, but there's another sort of form of it. Where let's say I did something like this. I did something like ABC plus 1. I'm going to get ABC 1. Now, I'm taking two things and I'm adding them together that are of different types. I'm adding a string and a number. That's something where just at the base level, like if you have two types and you're trying to concatenate them together, that's not something that is immediately obvious to JavaScript. It kind of has to do some finessing to make that work. And the rules of the language are such that if you have this number, what it does is it takes that number and first it converts it to a string. And then once you have the two strings, you can then put them both together and that'll work. Another case where this sort of thing will happen, you guys are familiar with the backtick strings from JavaScript maybe? Or you can do like templating. So I could do something like if I had var a is equal to test, I can go like test and then more stuff here. And then it'll template that in. Well, if I use the right variable, it'll work. Do something like that, where it'll template it in. Well, in a similar sort of way, if I put 1 in here, it has to coerce that 1 into a string to make that work. So you might be kind of seeing where I go with this, but if I had var a is equal to an object, and I go like this, object, more stuff here. So what's happening is whenever JavaScript has to coerce an object into a string, it uses that toString method, or that's one of the ways it can do it. And it turns out an object, so that's how it does it. And the way that a string converts into an object is by this very unhelpful bracket, object, object, bracket thing. So if you run into this sort of problem, what it most likely is you are trying to take some sort of data type that is not a string or that cannot be easily turned into a string, and you're trying to turn it into a string, like an object. Or there's other cases with other types of objects as well. Like with an array, it was nothing. In fact, curious, what's the array case going to do? I don't know it off the top of my head. OK, so that's a little more sensible. It converts it into a bunch of things that are comma separated. That kind of makes sense. But you're not seeing there like brace 1, 2, 3. You're seeing this sort of stringed version of that thing. What do you guys think of this?
Surprised I've never seen it on screen.
So are you saying that there's not actually anything wrong with this?
No, it's perfectly valid JavaScript. It's probably not something that would be helpful. So usually, like, it's not something you'd probably ever do on purpose. But it's.
You made a mistake. I mean, you probably made a mistake somewhere.
Yeah.
Because of your data types.
Yeah. So most likely, like, if you did something like I had a variable a is equal to string, and I somehow was in a situation where some sort of other object gets coerced into a string type, like an object gets coerced into a string. If that happens, the way it's going to get coerced, it's going to look like object object. And there are historical reasons why they are, and I don't fully know them, but that's how it ends up working out. And with different objects go in different ways. Some of them are a lot more sensible than others, like a regex. If I did something like, OK, so I set that equal to an empty string, and then I do something like, well, I'll do it without a. I go like test plus, and then I make a regex, something like dot plus. That's more sensible. Like if I were to do like the string version of this regex, the way it's coerced into a string is just like its literal value. That makes a lot more sense. But JavaScript's kind of an old rickety language. It's been around for many years. It was originally developed in 2 weeks by one guy. It's really not a language. It has a lot of weird little gremlin-y behavior. And object-object is one of those little weird gremlin-y behaviors. So the moral of the story is, if you ever see that, it's because you have an object of some sort that's being shown as a string, and most likely it's because you don't actually want the object. You probably want like a key inside of it. Like for example, if I had var a is equal to hello world, and I did something like hello a, I'm going to get hello object object. When maybe I actually meant something like hello, which gives me hello world. Like, you see the difference there, in which this I'm talking about the object. Or this I'm talking about the key within the object, or the value it maps to world. So that's a string, so that makes more sense. Where in this case, I'm talking about the object itself. So that's kind of a common place where this can happen. This doesn't really happen to me all that much because I've just trained myself to avoid it. So I'm actually having a hard time thinking of other places where this can happen. But this is the thing that comes to mind immediately, for me at least. Have you guys run into this in any other sort of situation you want to talk about, or?
I got an error that said uncaught promise when I was trying to do my JSON array.
Yeah. Okay. Yeah. Okay, so let's talk about that afterwards. But does anybody have any questions about this in particular? Sounds like no. Okay, cool. Yeah, so uncaught promise. I purposefully was very vague on promises with you guys. And that was because I didn't want to overwhelm you. Promises get very deep very fast. And I think that this class is a pretty wide variation in like people with different skill levels. And that's not to say like any of you guys are doing badly or anything like that. You guys are all doing amazing. But it's just some people catch onto this stuff more quickly than others. And I kind of wanted to keep it relatively basic and didn't want to try to go crazy advanced and confuse people. So the whole uncaught and promise thing, there's actually another method on promises we didn't talk about, which is .catch. So we have .then, and that allows us to run a function when the promise, something happens successfully, like you get a fetch response back and everything works well. .catch is another method you can have on a promise. And what .catch will do is it'll allow you to effectively run a function, just like then does, whenever there's an error that happens. So that error could be like the fetch call fails in a very bad way. Or the error could be that something happened wrong in a then before the catch. Like if you had a, well, okay, I'm getting a little ahead of myself, so I haven't talked about chaining. But effectively, when you see that whole uncaught in promise thing, what that means is that there's no catch there to catch the error. So what happens is if you don't have that catch in place, it will just log that error to the screen, just like it would normally in JavaScript. So if you see uncaught in promise, most likely look at the next part of the error. And the next part of the error is going to tell you the actual problem. Where uncaught in promise is kind of more of a red herring. It's saying this error happened in the promise and it was never caught explicitly. So we're just going to print it to the screen so you don't just hide the error and no one will see it. Promises used to just hide errors. And I will tell you that was frustrating as heck. Imagine something happened in your program. You don't see any stack trace. You just say, you don't see you don't see it work either. And you have to just kind of like just brute force play around. And yeah, that was bad. But luckily, that's mostly resolved these days. Did that answer your question?
Yeah, I mean, I was reading somewhere where it like say that whatever I was trying to call was not there in time. That's why I was getting the error, and I wasn't quite sure because, like, I mean, when I do console log, like I see all this stuff there already. That I'm trying to do. So.
Yeah. So what's the next part after? Like, what does the full error message look like? Okay. Well, maybe later on. Okay. Yeah, but if you see something like uncaught in promise, just look at the next part of it, and most it sounds like that's what you're doing, but you can effectively treat that first part as just it doesn't really mean anything, or it does mean something, but it's not important in this context. Okay. So there were two other things I wanted to talk about. One of them was the thing, Eva, you asked me about yesterday, the spreadsheet of all the terms.
Oh yeah, spreadsheet.
Yep. Yeah.
With the native code thing.
Oh yeah, that's what it was. Yeah. Okay. So. Okay. Web browsers, they are not written in JavaScript. They are written in lower level languages. So I'm guessing you guys probably haven't been exposed to programming languages outside of JavaScript all that much yet. Maybe you've done a little research on your own and you've run into them. But in this class, as far as I know, JavaScript's really been the only programming language that's been discussed. There are as many programming languages as there are computer scientists. Like people often have this sort of thing where they want to make their own programming language because they think they're cool or something. It has 2 users and it dies after a couple months, and that's great. There are, however, some computer scientists who have been very successful. And JavaScript is the outcome of one that was backed by a company, and Python, another language you've probably heard mentioned, is the outcome of another individual who I think originally was acting alone, and it got adopted by a couple companies. And there's a couple, like Ruby's also has a similar story, and I mean, yeah, so there's a lot of different programming languages. And the web browser is written in a language, or Chrome is written in a language called C++. C and C++ are probably also terms you've heard thrown around maybe. C and C++ are programming languages that are much lower level than JavaScript. In effect, they give you access to the raw computer. You can do things like run a raw instruction on the CPU, or you can do things like do operations that maybe are like potentially unsafe, or something like in JavaScript. If you did something like tried to write to an arbitrary memory location on the computer, there's actually no way in JavaScript to do that. They don't expose a way you can just write to memory. Or in something like C, you can just say, I want to write this byte to address 0, and the program will happily let you do that. It might crash, but it'll happily let you do that. So why did I bring this up? Well, Eva had asked about this whole native code thing. And if I do something like maybe array.prototype.map, we'll also see that. Map native code. Well, because Chrome's written in C++, at some point, you can't, the way the JavaScript runtime is written, it can't be written in JavaScript itself. It has to be written in something like C++, because like if it was written in JavaScript, you need a runtime to execute the JavaScript it's written in. And you have this sort of problem where like you need to have a base runtime that
you run into this recursive problem where you need the runtime to execute the runtime. So you can't write the runtime in JavaScript itself. So the runtime is written in C++. And methods like map, or like all these built-in methods, or like before, whatever I had that had Eva mention that. But a lot of these sorts of methods, they're written in C++. So if you were to go to, if you were to find the Google Chrome source code, which is publicly available, or Chromium, the open source version of Chrome, is publicly available, you can take a look and you can find the C++ implementation of array.prototype.map. And you can read through it if you want. And like, it's actually a very fun read if you're into those sorts of things. But I'm a little masochistic, but anyway, the reason.
You teach all of this stuff to yourself? Like, pretty much?
Mostly.
Amazing.
It's just time. It's just time.
I don't know.
Anyway, native code. The reason why we see native code in here is because the code that's actually map under this behind the scenes is C++. And it's not going to print out C++ to us, but it wants to give us some sort of like message that will at least tell us what's going on. So at least in Chrome, the way they decided to do that was just by printing out native code to you. So what that means, if you see that, it means you've printed out something that exists, that's a method that you can run. It's not written in JavaScript. It's written in C or C++ or whatever language the browser was written in. And it's just, you just have to trust it works. And like, if it doesn't work, you have to raise a bug with the browser. But it's not something you can it's not a method you can modify. You can't like look at the map source code and modify it in JavaScript. If you wanted to modify it, you'd have to modify it in the Chrome source code and recompile Chrome or something like that. It's not something you can do in JavaScript. So that's what the whole native code thing's about. In different browsers, you'll see different things. I work in Chrome mostly, so I don't know off the top of my head what it looks like in other browsers. But this isn't like a standard. Like, it's just someone at Chrome or Google picked that one day and no one objected and they went with it. So yeah. Okay. Any questions about that, or sounds good? Okay, cool. So we got to talk about the spreadsheet, and then New York's time exercise, and then also if you guys have any other stuff you want me to talk about. Now this is my last day, so like it's like this is your last. Well, this isn't your last chance. I'll be around, but this is your last chance in a class day to ask me questions.
Too, Marky, when Jeff left, we were almost in tears. That wasn't here, but it wasn't Jeff.
Okay, so we need to find that spreadsheet, and I think I posted that in Slack, if I remember right. Yeah, up here. Cool. Okay. So what I did is I this morning went through and put together a section on this spreadsheet for every single day and put together the terms that I thought were important. And I left some of them blank because I didn't have time to fill them out. So I figured we could either do them here communally in class and kind of add to the rest of these, or you can I can do them on my own and give it to you guys, whatever you want.
Can we have it? Where was that?
I put it in Slack.
Oh.
I'll repost it if you want.
All right.
Okay. It's that message. So I guess I didn't get a chance to look at Joey or Gus, I think, or Max, whoever you said otherwise did this sort of thing. I couldn't find their versions of this, so I just kind of made it up. Like, I don't know if this is roughly what they did, or if there's things that we were missing, or.
Yeah, I mean, it was just, he went back through kind of just, yeah, I mean, this is like much fancier.
Okay.
It was basically just stuff that we talked about, and then he copied more code because it was more JavaScript and functions and stuff, right?
Yeah. Okay. Cool. So do you guys think it's worth going through this in class, or do you want to like read it on your own, or what do you think would be helpful? Both? Go through this right now. Okay. Cool. Okay. So day one. So first we have networking. The act of connecting two computers to share information. So that's going back all the way to the first day. We have two laptops. We have a network that's a broader thing that these two laptops are on, and we can somehow send information between them. We were with Netcat when we were using with that's with TCP. So TCP is a way of sending information over the network. We got this broader network you have a TCP, you can create what's called the TCP socket, which is a connection between two computers, using the network as kind of like the backbone of that TCP socket. And you can send binary from one computer to the other, you can send data back and forth. And that's exactly what we were doing with Netcat on the first day. And I just defined TCP socket, so I'm not going to say that again. But IP address, an IP address is a unique identifier for every computer, like a mailing address. So that's where we did that exercise where I made that spreadsheet. And all you guys put in your IP addresses. We used ifconfig. You ran that. You found your IP address. And it didn't work in class, but the couple people I did it with the next day afterwards, we did it. We actually did do the exercise correctly. But you had to send a message to yourself on the same computer. But technically, with that IP address, you can connect to someone else's computer. And if they're running a server, you can send them a message. So that IP address acts as a way that you can locate someone else's computer on the network. OK, so then DNS. There was actually a conversation about DNS in the Slack channel today, and it sounds like you guys are going to learn much more about it very soon, which is great. We only touched the bare metal on it. We didn't go very deep onto it. So all we talked about is DNS is a way that you can take a domain name or any sort of identifier, like example.com, or like localhost, or like I don't know, like maybe like Eva's laptop. And you can take that and turn that into an IP address. So it's a way, it's a service that'll do that for you. You give it, like, you ask it a question and it gives you back a response. And you will soon talk about much more than that, but that's all we talked about in this module. Ports. So ports we talked about at the very beginning. Those are like the walkie-talkie channels. If you have a computer and you want to send a message from one computer to another, you have to pick a unique port to send that message along. So you have to send a message from, like, if you want to, maybe you want to do like port 5000. You have to be listening on port 5000, and you have to send something to port 5000. If you're listening on port 3000, you send something to port 5000, that's not going to work because they're different ports. So it's like the different channels of communication. You can send things on multiple ports at the same time too. Totally cool to do, done all the time. Protocol, an agreed format that can be parsed or understood by humans or computers. So something like JSON is a protocol. Something like HTTP is a protocol. They're effectively just a handshake agreement, two people agreeing this is the way a sort of message or a sort of bit of text will look, or a sort of bit of binary, or sort of bit of information will look. It'll follow this sort of format. It'll have this stuff here, this stuff here, this stuff here. And whenever you receive it, you can just expect it to look like that. And it's a sort of expectation that both sides of both the sender and the receiver will have. I'm kind of flying through this stuff. Like, interrupt me if I'm if you want. OK, protocol, Netcat. So Netcat's what we used on day one. It's that command line application where you can make a TCP socket, send information from one computer to another computer. In actual industry, well, OK, I should step back. In web development, you will basically never use Netcat. Netcat is like a tool for Unix hackers like me who are kind of crazy. But I picked it because I know how to use it, and it demonstrated the point, and it worked out quite well. But like, it's good to know it exists. You can use it to send data from one computer to another. And if you ever get into like lower level development, or you get into like Linux or Unix system administration, you'll run into it again. So hey, I gave you an extra piece of tidbit of knowledge there. So great. So Netcat, we already talked about that. So that's day one. Any questions? OK, day two, HTTP. Hypertext Transfer Protocol, the protocol that web browsers use to communicate. So it's that protocol that has like headers and a method and a URL. And it's what we did is we sent it with Netcat. So we had originally we had just people sending it back and forth, and then we had a server. So effectively abstracting away that person receiving things. I put that server up in the cloud over at DigitalOcean, and you guys could send messages to it, and it would respond for you. So it would take care of all that, the one side of the communication. So HTTP is a protocol. I think I mentioned that, but if I didn't, it's a protocol. It's a protocol. HTTP request. So an HTTP request is the act of sending data from the client, from the person making the request, to the server, to the person receiving the request. So in the case of you making a request to something like module5.tk, what you were doing is you were the client. You were putting together this protocol, this HTTP request thing. You were putting together that protocol, and then as text, you were just sending those characters over the wire one at a time. You were shooting them over to the server. Server received them all into a big bucket, and then took all those characters and it parsed them, went through it and said, OK, here's the method, here's the URL, here's the version, here's the headers, here's the body. Took all that stuff, extracted it out, and did stuff with that information. So that's an HTTP request. So then there's different parts of an HTTP request, like the method and path and version. And those are all different fields. Like a method is like the get, put, post, delete, patch, options, all those ones we've talked about now at this point. There's a bunch more than that too. If you click a little drop down in Postman, it'll give you a list of like 50 of them or something crazy like that. You'd never use the majority of them, but apparently they exist for some reason or another. But in general, a method is like, it describes exactly the sort of operation you're performing. Like a get means you're trying to read something from a server. A post means you're trying to send something to the server. A put is a similar type of sending operation, but it usually implies like an updating or some sort of like modification action. A delete implies deleting something. That's relatively obvious. Did I say anything in here also valuable? No, I basically just said that again. Okay. Path, that's like that's the part that's like it's got like the slashes in it. And you have like slash fruit or like slash users /5. That's the path. The path is different from the URL. We're going to talk about the URL in a second. HTTP version. So that's like HTTP /1.1. It's the version of the protocol. And also, I don't think we touched on this later on, but it's really great to include versions in protocols, because what's great about that is if you include a version, if you later on want to make a change to the protocol, you can change that version around, and then the other person receiving the data then knows, oh, this is a different version. It looks a little different, and they can have like, it's very easy to change the parsing logic based on that version. You can have like an if condition and say, if the data you got's version is 1, parse it this way. The data you got's version is 2, parse it this way. So it provides a kind of future-proofs your protocol. Any sort of protocol worth its salt will have a version. Although I say that and things like JSON don't, but that's because they've just been static for so long, no one really cares. Okay, HTTP request headers. So those are the things in the request where it's like the key : space the value, key : space value, and they're new line separated. And the key is normally in like uppercase train case, so like capitalizing each first word with the dash in between it, like content type, uppercase C, the uppercase T with a dash in between, things like that. And headers normally include request metadata. So things like the content type is like the sort of data type that's in the body of the request. Like accept will contain the data type of the thing you get back. That's not really information about the request itself. It's like, well, I guess it is information about the request itself, but it's like, it's not information about what exactly you're trying to do. Like if you were creating something with a post and I was maybe creating a new user, the content type of that information doesn't really matter as much. It's more like additional metadata. It's not necessarily relevant to creating the user. It's just like, it's more about how exactly the request should be processed. Or like authorization, that's not relevant to how the user is created. That's relevant to like, do you have access to create it? It's kind of like ancillary information. Okay, HTTP request body. So I kind of touched on this a couple times already, but it's that additional like main payload information you have in your request. So if you're creating a user, it would be like the user information you're going to create. Or if you're, I don't know, like if you're updating a user, it'd be the same sort of thing. Or if you're, yeah, those are the best two examples I can think of. But any sort of time you need to send information along with the request that is like a core part of the request. Like it's a requirement for the request. It's not really ancillary. It's like a key piece of it. The body is usually the thing you want. And then status code. So that comes back in the response. So in the response, we also have like a response headers and response body and all that stuff. I didn't enumerate those explicitly because it's pretty much the same thing, only replace every explanation of request in my definition with response, and you got it. But a status code, or the response status code, that's like the 200 number, or the 400 number, or the 500 number. And just as a review, the 200 means all good, everything happened successfully. The 400 means it's something went wrong and it's the fault of the person requesting it. Or yeah, it's the fault of the person requesting it. Yeah, I said that right. And then 500 means it's the fault of the server. So you gave it correct information, but the server didn't do something right. So typically, if you see a 400, it means you need to change your request somehow. If you see a 500, you need to contact the person that runs the server, tell them they're doing a bad job running the server. And if you see a 200, it means everything's good. Okay. So that's day 2. I really talked fast there, sorry. But does that make sense? Any questions? Okay, cool. So we're going to keep on rolling then. Day 3, Postman. So Postman is a graphical tool for making HTTP requests. does the same sort of thing as Netcat, only it provides you an interface where you can click on things, and you can instead of having to type out like the whole entire request, you can click like a button and it'll say like, I want to make this a post request. And you can click and type into a box and you want to say like, this is the path I want to use. And you can click and you can say, these are the headers I want to use. Instead of having to type that out in the terminal like each time, you can configure it in this sort of interface and you can click send, and it'll do that typing for you. It makes making requests a lot simpler. A URL. So we didn't talk about URLs in the previous day, but a URL is effectively a way of taking a couple bits of information and combining them together. And this is done because often these are sorts of pieces of information that whenever you send them to somebody, you always want to send them to them together. So it just kind of makes sense to combine them into one format that's just easy to understand. The URL is kind of like a protocol. It's you kind of know you know where the path part of the URL is going to be. You know where the domain part of the URL is going to be. You know where the port part, where the protocol part is going to be. So I kind of just settle the parts, but usually you start with something like http:// that says exactly the protocol you're going to be using for the URL. And you have your domain name, something like example.com, or an IP address could go there too, the thing you're going to talk to, effectively that first parameter you'd pass to Netcat. You can optionally put a port after it, like :some number, to say I want to go to a specific port, like module5.tk :5000 was something we did at one point. And that says, I want to connect to module5.tk on port 5000 in particular. And then after that, you have the path part. So that's like the /bits that we talked about before. And it effectively, that URL lets you combine all that stuff together. And it's very front and center in most web browsers. And you can paste it in there. And it's the way that often it's when you want to talk about a location on a server, like a location in an HTTP API, the way you do that is you say, this is the this here is the URL. This is where I'm going, and you give that to someone, and it works as a very good communication mechanism there. So that's URLs. Query parameters. Those are those extra little question mark parameters you can put at the end of the URL to say these are extra things you can include. Query parameters. The difference between a query parameter and the body, you might think that's kind of a fuzzy difference, and you're totally right, it is. And usually the way it works is query parameters are reserved for things like filters or any sort of like other information that maybe isn't directly relevant to the request, but it's different than headers though. It's really hard to explain. It's one of those things where you just start to get a feel for where things go where. I would say that probably the most common use for query parameters is with a GET request. You can't have a body in it, or you shouldn't have a body in it. So therefore, what people usually do is if they have parameters as specified in the GET request, they'll include those as query parameters. So you'll see something like maybe, let's say you're making a request to get the or like Google, you're making a request to search Google. If you look at their request, they're making a GET request. You like click search and your browser makes a GET request. Browsers always make GET requests by default, how it works. So the browser makes a GET request, and that GET request URL ends in $Q equals your search term. And that's sort of a standard, and that's what Google decided. That query parameter means the search term. And because you can have a body in that GET request, it's just where they decided to put it. So between that and headers, it's easier to do it in the query parameter because it's like more visible in the URL. So it's what they decided to go with. So that's query parameters. And curl. Curl is the thing that you guys are very polar about. Either love or you hate curl. Curl is a tool that is a command line version of something like Postman. So it's like Netcat, only the main difference being instead of typing in the request, typing out the full HTTP body, you instead type out, like you want to say, I want this method, and I want this URL, and I want these headers, and I want this body, and there's a bunch of other things you can specify too. But you tell it all the parameters, and it does what Netcat would do behind the scenes for you. It like connects to the server. It types out all those characters, given the parameters you've given it, and then it sends back the response, and it prints out that response for you. And I really like curl because I'm a Unix person. I do all my stuff in the terminal, but I totally get if you don't like curl. That's totally fine. You need to know what it is and be roughly familiar with it. But past that, you don't have to touch curl if you don't want to, and it's totally cool. But curl's awesome. You should use curl. So anyway, so that's day 3. I think day 3. Yeah. How about any questions on that? Okay. So day 4. Fetch. So fetch is a tool built into the browser to make HTTP requests. It's just like a Postman or just like curl, just another one. It does the exact same thing. It's just it's built into a web browser. So you can, in JavaScript, you can now make these sorts of requests. Something like Postman, you can click to make the requests, but you can't do it in code. Something like curl, I don't want to say you can't do it in code, because you can do it in code, but you can't do it in JavaScript. You can't run curl in JavaScript. Like you running it in the terminal, you can't do that in JavaScript very easily. So fetch is one way you can make requests in JavaScript. Now, that same day, I also mentioned Jquery.Ajax, which is another way to do it. Jquery, something I'm guessing you guys maybe have heard mentioned before, has a method inside of it called .ajax, and that allows you to make HTTP requests in the web browser. Just another way of doing it. It actually was kind of the precursor before fetch existed. It was kind of the more popular one. You can use it if you want. I don't, and I'm teaching you fetch because fetch is built into the browser, and it's probably good to know that. So you're welcome to use whatever you want. Another popular one we use at work actually is called Axios. It's not too bad either, but there's a bunch of these tools. Fetch is just the one that's built in. And then promises. Promises, I'm guessing, they're another very polar concept in this class. Actually, I don't even want to say polar. I want to say in general negative. And like that's fine. Promises are complicated. I told you guys the most simple stuff I could about promises. But in general, the idea of a promise is it's a value that represents a value that's going to come later. So an example I've started to use is you have a present, like Christmas present. And you get that Christmas present, and when you have that Christmas present, like you can look at it, you don't know what's inside, but you know there's something inside. Or maybe there's going to be something inside later, but there's a space for something inside the present. And then at some point, you unwrap that present, and when you unwrap that present, you see the thing inside. And effectively, the promise is the present, and the value you get when you use then, and you have that function that you pass into then, the value you get in the function, that's the thing inside the present. So, and if you want to bring the analogy even further, let's say you have a delivery man who brings you the present. The delivery man is fetch. So the delivery man brings you the present, and then you unwrap the present. You have this promise, the present, you unwrap the present, and then you have the thing inside of it. So if any of you guys want, and maybe get done with the New York Times exercise or something, or if we do this dinner thing tonight and you guys want to chat about it then, we can go more into promises, because promises are actually one of my favorite things about JavaScript, and I've spent a lot of time studying them. So I do have a decent amount of knowledge in them. And if you want to go deep on promises, we can go deep on promises. So anyway, that's day 4. Any questions about that? OK, cool. So day 5, I didn't actually write anything out for. Either do that together, or I can kind of just rattle it off and can do whatever. Yeah, I don't know. So these I'm probably going to steal the definition straight from the slides for these. So maybe I'll just save that till later if you guys don't mind. If you want to do it together, though, we can do that too. So if you guys don't have a preference, I'll do it later. OK, cool. So content type header, that specifies the value or the type of data that's being sent in the request to the server. So let's say you're making a post request. In the body, you put some JSON. It's common practice to specify a header in the request that says content type and set it equal to the value of application/JSON. And that indicates this data that's being sent to the server is JSON data. In a similar sort of way, well, actually, maybe let me explain why that is. So why that is because the server has to know what to do with that data. And many times servers are written with the sort of notion they can parse multiple protocols. They could parse, you heard me talk about YAML before. They could parse YAML. They could parse XML. They could parse just plain text. They could parse a CSV, give it a bunch of different data. And you could have some code that tries to guess what the type of the thing is. Like it would say, maybe if it starts with a curly brace, it maybe is JSON, just guess. But it's much better to just know for sure. So that's where something like a content type comes in. Except same thing, but for the response. So you as the requester ask the server what exactly data you want to get. And that's the data you're going to get back in the response. Now, it's not 100%. The server could disobey you and give you back whatever data it wants. It's like a request for it. You're saying, I'm pretty please give me this sort of data. But unless people are really evil, they don't do that. So yeah. Authorization, which it looks like I spelled wrong, and I'll fix that. So the authorization header, that is a header that's specified to allow, or the standard way that you specify a header that allows you to say, to give information declaring who you are to the server. So that could be a token, that could be a username and password, it could be some other things too. But the ones I often use the most are like a username and password and a token. We talked about those in the slides. Unless you guys want me to, I'm not going to get into that right now. But it's a way you specify who you are. And a cookie does a similar sort of thing, only with a cookie, it's a different sort of mechanism of accomplishing the same thing. Instead of the cookie, every single time you send a request, you get back in the response that set cookie header. And the browser, now keep in mind, this is the browser only. Something like curl or Postman isn't going to do this for you. But the browser will take that set cookie header. The next time you make a request, it'll include it in the request, and it'll send it off to the server again. So because of that, every request that's made to the server has the same cookie in it. And because of that, the server can then have a mapping. Think of like a big object on the server side where it's like keeping track of cookie value mapping like the user information. So they can always just look up the user by that cookie. That's, well, roughly. A bit of an oversimplification, but roughly how it works. We'll talk about that much more in the next module. OK, so set cookie header, we just talked about that too. User agent header. User agent header, we went into a whole big story on that, and that was a fun story. But the user agent header defines, it allows the client to specify exactly what sort of client they are. Now, it's completely optional. You could spoof it. I could make my user agent header say, I'm on a Mac, even though I'm on Windows or something. That's totally fine. But it's voluntary, and just usually it's used for analytics. So if you ever used something like Google Analytics before, you see all that sort of stuff about like which browser the user's on or like what operating system they're running. A lot of that sort of stuff will come from the user agent header. And I mean, you could spoof it. You could say you're on mobile and you're actually on a laptop or something. But usually people don't do that. It's reliable enough for analytics where people will be fine with it. So really, it's more just you should know what it is in case you run into it. But in practice, you're not really going to ever send it in requests on your own. OK, host header. So host header is that header where when you make a request to the server, when you're making that request, you're taking that domain name you're making the request to, example.com if it's a domain name, and you're looking it up via DNS and giving the IP address. So you get the IP address back. That's like the mailing address where you need to go to send it the information. When you make that connection, effectively, if you're thinking about making that connection with netcat, if you type like netcat, the IP address, and then the port like you would do with netcat, and you hit enter, you've now connected, but you've never told the server your host name or your domain name. Because of that, often, if you want to use a server to serve multiple things in the same port via HTTP, somehow it needs to know from which thing you're requesting that information. Are you requesting information from careersandcode.org, hackupstate.com, from something else completely different? If they're all hosted on the same server, you need to somehow know where they're requesting it from. So what web browsers will do is they'll include a header in your request called the host header. And when you have that host header in the request, it has the domain name you're making the request to. Like it takes that part out of the URL and just includes it in there. And when that header is included, it means that now the server knows exactly where you're requesting it from. In other words, because that information is lost when you do the DNS lookup, it's a way to kind of pass that information along to the server in a side channel, another way to do it. So that's kind of the host header. You'll talk about that probably, I'd guess, in the DevOps side of things more maybe, which I know there's a module for that. And then custom headers. So HTTP, you can have custom headers. They all start with x-something. That's the standard. You don't have to do that, but just you should because it's standard. Please follow standard because people don't, and it makes everyone's life harder. Please follow the standard. So it starts with an x, x-whatever. You can pick whatever you want arbitrarily. That's why whenever you see examples where I say like include this header and some random header, I always start it with x, following the standard. So that's custom headers. And I mean, you can use it, specify anything you want that you think would be a header, just how it goes. So that's day 5. Any questions on that? OK, cool. So day 6, JSON. So JSON is a way of encoding JavaScript objects, arrays, and primitives in a format that can be sent anywhere text can be sent. So we can take a JavaScript object or array or any sort of JavaScript representation of something. Well, I shouldn't say any, but most JavaScript representations of something, and we can put this into this method JSON.parse, JSON.stringify, other way around. Put it into JSON.stringify, and it will give us a string version of that. That string version we can do with whatever we want. We can send it to a server in an HTTP request. We could take it. We could write it down on a piece of paper and hand it to somebody, and they could re-put it into their computer. But effectively, we can transmit it in some way. And then once we've transmitted it in some way, we then can effectively do the other operation. So stringify goes from the JavaScript version to the JSON string version, and then stringify goes from the string version, or sorry, parse. I'm getting this backward. This is not good. Takes the string parse JSON.parse takes the string version and converts that back into the JavaScript version. So you've got one operation to go in each direction, and you can use this sort of JSON format as like an intermediate way to communicate data structures between two systems. JSON is pretty much supported in every major programming language you will ever touch, or if it isn't, someone's working on a way to make it work in it. It's probably these days the most popular way to send unstructured data from one person to another. There's some competing ones, but it's probably the most popular. Dana, you're going to run the XML in your bus thing, which is another way of doing it. So have fun with that. We'll walk through it, but yeah. So I just talked about everything in that. So any questions about JSON? Okay. I didn't actually put together anything on the REST module because I need to do some more thinking about that. So I'm going to skip over that for now. And then cores and caching. So we have these two sorts of, well, okay, let me take a step back. When we make a request in the web browser, by default, we can make a request to the same origin. We have the same origin policy. We can make requests from example.com to example.com, or we can make requests from google.com to google.com. We can't, by default, make requests cross-origin. We can't make a request from example.com to google.com, or from careersandcode.com to, I don't know, myfunwebsite.com. You just can't do that. And the reason why we can't do that, we talked about this on Monday, or Tuesday. It's a security reason. I'll let you read to go back in the slides if you want to figure that out. But so the way that we can do this, the way we can make cross-origin requests, because we do need a way to do it. Like if I want to communicate with the New York Times or want to communicate with like some other API, we need a way to do that. So the way you do that is you use a thing called cores, and it's this mechanism called cross-origin resource sharing. It's a mechanism for making cross-origin requests in a web browser. However, because of these aforementioned security reasons, if you want to make a cross-origin request, the server has to be okay with it. So what you do with cores is before you make the actual request, you make what's called a preflight request. It's a request before the actual request. It's like a precursor. And what happens is this request happens to start with, and it sends the server all the information that the browser, about the browser, and about where exactly the request is coming from. This is something the browser does automatically. It's not something that you can turn off. It's just how it goes. The browser makes this request. The server receives it, and the server can decide, do I want to accept this cross-origin request or I want to deny it? If the server responds badly to that initial pre-flight request, the server can say, this browser should not be allowed to make this cross-origin request. And it will terminate with that nice little fetch error that'll say something about cores, access control, allow origin, all that stuff. I bet you guys have run into that a bunch. But it'll terminate with that sort of error. So if it's successful, though, if the cores request or the pre-flight request comes back successfully, then the browser will make the actual request. So in effect, I don't want to say all, because it's not quite all, but in most cases, if you're making a cross-origin request, a pre-flight request is required, and the server must respond successfully for it for the browser to be allowed to make that cross-origin request. Now, keep in mind, this is in the web browser. In Postman or curl, this isn't an issue. And as to why, read the slides or come talk to me and I'll explain it to you one-on-one. But it's not an issue. That security issue that we were talking about that was brought up before isn't an issue outside of a web browser. So that's cores. And then, so any questions on cores?
So, yeah, I did the security and I'm fascinated by it, but.
Yeah.
So in cores, so I make a request to a website, and does it have to like recognize whatever's in there? Is it like just recognizing my device or my identity, or it does depend on what I tell it?
In a roundabout fashion. It's usually more about, the most important piece is where did the request come from? Like what place did it come from? Like, did you make the request on example.com, or did you make it on like google.com or careersandcode.com or something? That's probably the most important piece. Okay. But it also will send along things like, what headers do you want to include in your request? Or things like, what method do you want to use? And the server could just say, like, they could have whatever rules you want. You could have something where, like, any request from example.com, so you take a look at the header in that preflight request that has example.com, and you could say any request that comes from example.com can use only puts and deletes. It can't use any other request type or any other request method. And you could have that sort of logic on the server side and respond back with the proper messages so that the browser just wouldn't make, like it would just fail for those sorts of requests.
Okay, so when you're talking about, this isn't really, like when you're talking about really secure servers, this isn't the only line of defense.
No, not at all. Yeah, this is more of a, this protects against some vulnerabilities in the browser, which have to do with like sharing credentials between different origins.
Okay.
Cool. Okay, so that's cores. Anybody have anything else? Cool. Oh, yeah.
I mean, it's completely different, but I'm still, what I'm struggling on is converting the JSON data to kind of a format.
Okay, let me get through caching and we'll start walking around. But yeah, after this, we'll touch on the New York Times exercise. So caching. Caching is a technique for storing the result of a computation so that future requests for the computation's result can be provided faster. So that's where we have that object outside of the function, and that function was storing its result into the object. And then anytime we ran the function again, it would get it from that object instead of computing it again, which made it faster. We did a little testing to prove that with console.time and console.timeend. You're clearing the cache. If you remove everything from that cache object, then when you rerun that function, it's going to have to recompute things because it no longer has the information stored that it computed before. So clearing the cache is it's a common technique or a common thing you have to do if you cache things. We talked about that quote, caching validation and naming things are the two hardest things in computer science are caching validation and naming things, something like that. And they for sure are. And if you don't believe me yet, you will understand very soon. So caching is something that's done with HTTP. We went into that on the presentation day, but so I talked about caching in JavaScript and then kind of extrapolated that to HTTP. And the last bit here, the cache control header, there's a header that you can use, you can return back from the server in a response. It'll tell the browser exactly how it should cache that information. Should it never cache that information? Should it cache it for a specific amount of time? There's a couple other options too, but those are really the two I'm most familiar with. So there's ways you can control how the cache works in the browser from the server. So that's pretty much the whole thing. So I'll go through and add stuff to this guy and do these guys. But that's like the whole module in, what was that, like 20 minutes or something? Very quickly. So hopefully that was helpful. Cool. Okay. So I guess pretty much the rest of the class, like if you guys have questions, get a hold of me. I'm just going to walk around like I normally do. My goal would be, by the end of the class, I would like to see people being able to take their careers in code data and write it to the screen. So either just write out the JSON on the screen directly, or preferably take each book and create like a LI for each book and like print out the title for each book or something like that. Effectively, somehow taking the information you got from the server and writing it to the screen. And then at that point, if you want to go create it with CSS, go for it. Yeah, and if you get past that far and you need more stuff to work on, let me know, and I can throw you some bones if you want. So anyway, that's pretty much it for the lectures. So let me help Anna first. Yeah. Sorry.
Anyway, so I have to do that.
Yes. What so you, oh, interesting. So, okay. Found this online, didn't you? Okay. Yeah, because you're doing something I didn't teach in class that I love you doing. But anyway, okay, so cool. Well, here's the response data. So when you get back that response data, what type of data is it? So if you were to like, okay, so you're logging at array. Okay, So can you go to your browser and show me? Yeah. Stacktrace here. It's not that great. You have a line of where it's happening. I think on that line. So, unexpected. Yeah, you got it. Okay. Okay, cool. So you're looking through there and printing all this stuff. So is that what you want? Or?
Well, I mean, it's kind of like the next step to what I'm going to do. So I go in here.
Yeah. Yep. But yeah. So okay. Let's see. First of all, try to just log out like just the string of the title of the movie. These times you're logging out an object. In that object, you have a bunch of different keys and they map to a bunch of different values. Take a look at these guys. Yeah, yeah. Like RSA or something? What do you have going on?
I have.
Oh,
Yeah.
interesting. Yeah, okay. Yeah, there we go. Setting a bunch of text to extract the key from the objects. Yeah, we have all that text, no strings, that text. I think this somehow take all that text and put it in the DOM. You now have all the results from your computation. You've gone to the server, gotten back the results, have those results, and now you've printed them out. You want to the goal of the second exercise is all that stuff and put it into a web page. Like create like a p tag, have like listen to it, and create a p tag, and add it to it. That's what. So yeah, that's it. That's that. Okay.
Like every time I try it, I see I have a
Yeah, so
do that, but every single time I can,
you want to do it there. And the reason why you want to do it there is because we're looping the access to these values. And we're really confused. This variable is very all the same thing, but in fact they're different things. You're using for each array. The function is called each item in that array. Calling it an array like that is a little potentially different. I'm not calling it array. So this is a data that what's on the left side here is in the array you're looking over. And the function is this function inside of this for each is called every single time that for every single item in the array. They've got an array of 1, 2, and 3. This function is going to be called for the first item, and this value here is going to be equal to 1. So then they call the second item, that second item is going to be 2. This function is going to be again. And then the third time it's going to be called, and then that function is going to be called for that value of 3. So effectively, this is that. There we go. This function here is called with this one first. Then it's called with this one. Then it's called with this one. So calling that array, it's a little confusing.
You know, if you want to start just pull this chair. Maybe.
Okay. No problem.
You know, making my way down. I don't know if you can help me with this, but I just can't get them.
Yeah. Yeah, I mean, I would say that.
Okay,
I thought
I just can't get it to display on screen.
And it can be very slow going, but it's, that's the way I'm gonna go to get the grant, I think, I think it's the walk for like hours and hours.
It might be your time to say.
Yeah. Well, that's all on your own, like, I basically just like point you in the right direction. You know what to
Nothing
do.
is displaying.
So like, the,
There though.
the thing is here, for each, let's bring in something like item. Because, is like each item is a, each
Body
entry
stream
in
is
your.
fine. That's what that means.
Each entry array. And we're
I
always
was
on
wrong with that. We don't
actually. Do you like, you know how to use for one and you know how to use for each?
Oh, yeah.
Okay, let's use for that.
That is just
Yeah,
just
for the four you want to do. Is you guys,
So,
well, set your for to start with.
yeah, so I've got all my data there. Even if what's long. Yeah. But I'm gonna send more.
That's right.
I think I did tell it to do that.
I'm just gonna be index. The, array.
Yeah.
You know, the index, you have to get each item correct. So probably something I would imagine like bar item is equal to array bracket I.
Yeah, so up here it told me 200. So that's,
Do this stuff, I just, call this out.
but I can't get anything in the body except for that weird. Alter.
Right, you need that a lot with that.
Yeah.
Yeah.
Yeah, you guys are set up great. It's the HTML, yeah. Start this.
So then I called it data.
Yeah.
Those JSON stuff first. Text. Yeah, this is, I know it's wrong, but I don't know what to do.
You're calling it 23 here. Here, and then calling, and then doing it again.
Yeah, I don't really understand. I had this snippet of code from another thing we did, so I can't quite remember. That's why I was reading this.
So there we go, we get all the indexes that array, so we're moving from the zero to
So
the
I
one.
was reading this
Zero.
MDN thing, inner L, inner
Each of these
HTML.
index.
But I don't really understand.
Convert it to the item.
Well, you're
array
not
that's
there
actually
yet.
indexed.
I think you were having
For
issues
example,
earlier.
zero here to turn into this entry here. One to turn into this entry
So
here.
this is really not even
The thing
meant
is
to be
number
anything,
here
but
for it.
just.
So how would you do that?
Yeah.
Exactly.
What are you getting? At
You're logging it out. Cool.
Oh, that's all the data there.
So instead of logging it out, store it into a variable. That's just so we can
Okay.
play around with it. Instead of.
So that part's good, but I can't get
Yeah.
anything.
Your
That's
text.
for
Would be
response,
part of
right?
it.
Yeah. JavaScript. Yeah, yeah.
Okay. We're,
There's something up here.
Yeah.
So that's what I.
right, so you're not.
When we move around, actually to our object in our array.
Here, that right over.
Yeah, definitely. That's just there. That's kind of that.
So-
I just trying.
Doing
I'm just.
creative T
Mhm.
paragraph.
Mhm.
And the inner HTML just says here's what I want to put it down.
Right, so,
So you can just
so there I want,
data if you want to put it down.
I want my response. Or my data. I want my data. Yeah.
Not put the object, you could do the response
Wait.
straight away. You could do
No,
text.
so you can do that if you have a multi-dimensional array.
You could either do, this is your
But
JavaScript object.
object, right?
You're-
Data.
I mean, you're not
Yeah,
far off.
yeah,
You want to
yeah.
do that.
Text is a
If you have a bunch of
Yeah.
text in the string,
Right.
you
Just
need
do
to, I mean, just like
text
you did before, when
related.
you're logging out that display, technically you do this sort of thing.
So data dot inner HTML equals
Time you want
text.
to log out,
Actually,
the value that is referenced by
I
the
don't want to
string.
name this data also. This is the same.
So,
If we're to declare
Doing
data,
something
you
maybe like
want a different variable.
the X dot display name.
Paragraph or whatever.
But isn't that what I want it to be? The stuff that got parsed out of the.
No, so that's like,
Object.
You'll use that when you want to iterate through and access the field of the
or
object.
display title.
Okay, so.
I'm just saying right here, you already
So
declare
we
your
have-
variable data.
So data, so data.
X is equal to this, and X is equal to that, and X is equal to that, and that.
Anything.
Okay.
So logging out X,
Because it's
log out
defining
this key inside of it.
data
Yeah,
HTML.
Key that is value
Okay.
that you have to do.
Changes with that inner HTML.
You can do it that way. if you want.
Equals what? That's the part I don't get. What's the next
So
step?
log it out.
So
I'm saying
that we try to do data
Log it out
in
and we'll log out each version of X.
to get,
Here,
yeah. Here, sorry.
Yeah, okay, so we're back to where we was.
And there you look at
You understand?
Yeah.
Okay. So now we've got these string X. X is each time that movie. Now we need to append that.
Oh.
You already have that up there. How do you go about
So
doing
it's just a
this?
string you add on the server.
right?
So, what you actually want to do is figure out what you want to actually parse through.
Yeah, so create your element. Check the text in it. Then you
I don't
come and add
remember
it
what we're
in.
trying to get exactly. We know he has a
Looks like you have most of what you need to do up there.
For Slack?
Yeah, okay. So
I know I saw it like the first day, and I don't
do what you
think
did
I
before, or do
had
what
it
you,
since.
what you guess you need to do. Do it.
That I have. We
You
don't
should.
But
You want me to come back, like, give you some time to look
Yeah,
at
you
it?
can
in
like, yeah.
document his final document. You're asking for help.
Figure it out?
Kind of, so I started doing like this, just getting one at a time.
Okay, so that's what he did.
Yes,
So this is
Where was
doing,
that?
so then I did all of them, and I get this.
I just downloaded the,
Oh,
this is
How do I
an
get- how
sample
do I get-
example on the GitHub.
So,
oh, okay.
So yeah, I just downloaded.
you're right,
Mhm.
I get all of them, but how do you get like, because in each array,
You want to get an array of all the strings, all the titles.
yeah,
Yeah. So like what you want as output is you want an array. So the first item being $20 per count, the second item being give you my value.
So
Third one being
Part of
yeah,
the
less
response
than
is a list of
$20.
lists.
Okay. Heard of
So
that
for each
before.
category,
Yeah.
Okay.
the books, you get
Try out that.
the top 5 books.
would I do it in the for loop?
No.
Outside.
If you're gonna use map, you probably don't need it for. Yes, what's kind of your thought process? What do you-
Well, what exactly do you want on here? That's the other thing.
All right, so this
Do you
is just
want-
everything.
So, for example,
So I
like
gotta figure
all
out.
of these,
What you need from
there's
that.
an object.
So I
right
just
here,
need
item in
the
the array.
Yeah.
So
title,
do you want
author,
like
and thumbnail?
the title and the author and the description for each one, or like
I'm not picky. Like, I just want you to render
just
something
get
for each
something
book.
there?
And if you want to get fancy, you can render more than that. I mean, if you remember mine from way at the beginning of class, I had rendered the image and like all of it.
Yeah,
Okay,
also we're gonna
so-
get images. which is nice.
I have to run.
Maybe easier to go to the API.
Yeah, I don't know.
and then
I had
you
images,
get
I just
in there.
rendered whatever I saw, so,
No, it's fine.
yeah.
Okay, so
So I guess maybe a place to start would be like, just make a P tag, and then inside of each P tag, put all the text for each book. But the title, the main P tag.
so just like this, right? Like how I did create all of it.
Yep. Yeah, exactly like that, now.
So I can I do,
You can do that in a loop. That's
yeah,
your
can I
good
do it for each Or would it be like a, yeah, so I'd have to turn. Okay, all of these are already in the array, so that's fine, so for each item in this array. Create a P. Can you do that?
Yeah.
Okay.
Inside of a
Maybe
foreign
we can, like,
or any
it
code
looks
you
like
run outside of a
like we're
foreign.
getting back in the.
Okay.
So. Yeah, I'll be it.
I have to go back to use.
Yeah. So you get the text, the title for each one, yeah.
Right, so for each. This array, okay, so this is what, I think this is the problem I'm having because. Well, first it's making.
What you're doing with the for loop, you could do that too. So effectively a for each and a for loop do the same thing. It's just a for each is like an abbreviated form of a for loop.
Oh.
What a for each does effectively is if you were to have like something like calling a function and passing in like first into that result bracket I bracket into that function, this was that function.
Oh.
So it allows you to like run whatever code you want for each item in the array. But if you feel more comfortable with a for loop, the reason you can't do that.
No, I'm just confused now. What would I write for array? Because I can't write this.
You write that.
I feel like I tried it and it didn't work.
Is this where you are, Caitlin? Where everything is just showing up?
About. Have you parsed through JSON yet?
Yeah.
Each
Oh, yeah, you did. Yeah. Just look, you're putting the text in there. Yeah, so you're probably in the same place.
So what do I need? Here I kind of got lost in case helping me. So, all right, so I got the data from the parse, and then I console log the data, and that's there. So then I call info as the document.
Yes, you created an element for the P. But you need to. Okay, so you're parsing your text as JSON.
Yeah,
You're locking up that JSON. If you go back to your term or your console,
yeah.
Here. Here's our JSON that we've logged out. So this is all parsed. This is like colored. So that's good. But what you're doing here, you're creating a single P element. Inside that P element, you're putting all the text of this thing, and then you're adding that to the body.
Right.
Now, what you want to probably more likely do is you want to loop over stuff in data, and for each entry in data, you want to create a P tag. You want to put like something like maybe like books. I think that was it. Like books, you maybe want to put like author or title somewhere. Yeah, title.
Okay.
So you want to loop through like this books array. Each entry in the books array, you want to add a P tag to the DOM, and then you want to put this title text inside that P tag.
Okay.
And then you want to keep looping and looping and looping. But in fact, at the very end, the goal should be you should have a P tag for every entry in here. You should have 15 P tags. The first P tag is going to have like this. The second one is going to have like this. And on. Does that make sense?
It makes sense.
Okay.
Just think about how to do it.
Yeah.
Yeah.
Definitely. First data is an object. First data results is an array. See,
So can I do like that?
you can do that.
Oh.
So you can put any sort of expression before for each of them, because for each it's being called on something. Oh, so it's go into DevTools. Take a look at the elements pane. Pull down in the top one there. Got 15 MVP tags. Or however many MVP tags.
what are you doing there? Explain to me what you're doing.
Okay, so it says a variable, creates an element. Oh, I didn't put anything in the p tag.
Yeah.
So then I need to. Okay, so I need to create. Another variable, right? To put it in the p tag.
I don't know if you have to. You should get. So this is a p tag representation right there, books. You should be able to do that on books. You can use like there's an attribute on books you can use to put stuff inside of the p tag. Wait. Although, I think I know what you're saying. You wanted to create like a text element.
Kind of like
I do that
where
too.
where then I have to push in like the data from each item in the array,
Yeah.
right?
So you could make, so you could create a text, like create exactly the method, but it's like document.create text
Text node.
Yeah, that's it. You can do that.
But that gets a string.
Yeah. So you could pass like element.title of the string, or whatever, element.whatever is the string.
Oh.
Whatever you were logging up before, yeah. Like,
Sure.
yeah, so there you were
This
doing
is a
that.
string?
That's a string. If you want to prove it to yourself, log console.log element in there, and take a look at all the logs you get. You'll see the title inside of there is a string.
So, okay, so I can do. Let's try this.
So you can't do that exactly.
Okay.
Because in this context, you have the index, and you're extracting the value out of this array by its index.
Right.
In this context, for each, it gives you the element. Effectively, it does the first part of that for you.
Right.
So how would you change it to work with?
Or without that.
Not quite. You got the right idea, though. The thing before this needs to be equal to an element in the array, not the array itself.
Oh. So just that.
Not quite.
Let me look.
Go back to your code for a second. So when you're looking through a for each, it's running this function here for every item in that array. But running that function passes it to a single parameter of that function that is the item in that array. In this case, you have element here. So element is equal to like the first item in this on the first time this function runs. It's equal to the second item that's in this when the second time it runs, and the third, and the fourth, and the fifth, all the way down. And that's effectively what does the looping in for each, that function running over and over and over and over. So, how do that? You do something like log that element there somewhere. Sorry, not everywhere. Well, so we'll start, but go back to your code for a second. Yeah, comment out the 2 lines below. For now, you got an error in there.
Oh. Okay.
Does that make sense?
Yes, but now. So I need to just do. I'm just doing.
Want to come back to you? Let's go back to that.
Yeah.
Okay.
I think I'm gonna have to do it. I mean, like.
A loop inside a loop.
Yeah. Well, we said it all because I mean, right now I'm getting a.
Oh, nice. Cool. Okay. You could do a loop inside of the loop, or you could effectively do the same thing, but not have to have this. You could just duplicate this code over and over inside of there. You could create another element for like the rating, and you could like render the title and render the rating, and then loop back, render the title and render the rating. So You could do it that way. Yeah, no, you could do that. Yeah, totally. You could have a, sorry I keep saying could, there's a lot of different ways you can approach this problem, and I'm not sure exactly what you're trying to steer towards. But one way you could accomplish it,
Oh, I got
if you wanted to, you have a array I display title, you do something like array I display title plus array I rating, and add them together, concatenate them together, and then add that all that stuff to that each one. And then you have a bunch of each ones with the title and the rating together. And then like add it later.
Yeah.
Yeah, you could do it that way. Yeah, there are a lot of options. I'd say start with the concatenating. That's maybe a good first step. So just try to only modify this one line here. But in a similar way that we're doing this, get the display, get the rating, however, wherever that exists in the object, and just add it to the display title, all inside of that X variable. If you do that successfully, you should see something like the title and immediately after it the rating. You can put maybe a space between there if you want it to look nice or something. So go try that out.
Yeah.
How you guys doing?
I don't know, man.
Don't even know? Okay.
I don't know. What's happening? I'm just staring at my screen. I have like 5 different ambient things open. I can be here.
Yeah, okay. You parse the data.
Right, so I got there. Okay, cool. How do I write that as a for each? Like I can't do response.results.book that for each, like everything, you know? Like now I'm like, I don't know what to do now.
Sorry, I gotta look at what the data looks like here.
That's fine.
Results.
I get a little unwieldy. Like,
Yeah.
I don't know.
No, I totally get where you're coming from. It's I think that
Yeah, you just change.
okay. Okay.
Yeah.
I think so. You can still do it with this endpoint. I think you're requesting the wrong endpoint, which is part of the reason why. So really, that's not really necessarily an important part of the exercise. It's more that just you're fetching data and you're somehow running it from the screen. So if it's the wrong endpoint, whatever. But in effect, let's say, so either you can try to figure out the right endpoint. If we just want to get something to work, which sounds like that's what you want to do.
You got it.
Let's say you were to like loop through, I like by links. That looks maybe good. Let's say you wanted to loop through all the by links in here. This is not a good job. So I'm just going to start. I'm going to just write code. Response. Start with that. Reload it. So we've got that. That's it as expected. Oh, wait a second. Oh, wait, there are books in here. Oh, never mind. We can do books. Books is more interesting. Books has like got more stuff we can do with the books here. We've got images. Yeah, this is great. Okay, cool. So I have this object. I have a key of results that maps to another object. I've got a key of books that maps to an array. So it looks like you've kind of gone down the right path here. Response.books.
Yeah.
Or response.results.books. Yeah.
Books, and then call it as X, like just to see if I could get it.
Yeah. Okay, we got that.
Yeah, right, but
Yeah.
now, like, now we're ready.
Okay, so now where do you go? So you did something like 0 or something like that.
Right, so I could see if I could just get one of the objects.
And there's one of the objects. Does that make sense?
Yeah.
Okay, cool. So now you want to sort of loop through this.
Yeah.
Yes. Okay. I'm just going to start with here. I'm going to make this a multi-line function. Just so that it's a little easier to read. So do it all in one line. A little annoying. Doable, but okay. So we got this. Go back to logging out to your right. Okay, cool. So typically, when you think of looping through an array, how do you accomplish that? Like, what tool do you reach for?
Well, if I'm looking for an array, I can use
Use a for each. Okay, let's do it for each. So what do you know about for each? Yep.
Okay.
Yeah.
And it'll do the same function. Everything you call it.
Exactly. Okay. So you got for each. Got for each good. We won't give you a new array. That's map.
Right. Okay.
So if you return things from the function of for each, it just goes away. If you do map, it'll return you back an array with each thing replaced.
Shoot, that's the difference. Okay.
Yeah, that's a difference. So if I do something like for each, do console.log I, something like this. 1, 2, 3. I'm gonna run this function for each of these things. I just said that, so I'm guessing you understand that. Okay, cool.
Yeah, fair, but it's always good to see.
Yeah, definitely.
Examples are good.
Definitely. Okay, so you got that. Do the same thing I just did, but for this box array.
Okay.
So I did add A here. I called for each on A, I put to the function, and that function takes a single parameter and log out that parameter.
Okay.
So
But I don't have, like, this isn't saved as, do we need to do the very?
you could, but you could also just put dot for each after it.
Can I really do
You
that?
can really do that.
Wow, okay.
Do you?
I'm like, I'm starting to get me.
Well, okay, I mean, this often people do put this stuff in variables to try to make it easier, but this here is an expression.
Can I watch with you guys? 'Cause
Sure. Yeah. So
No, that's why I was like, please help me, because I'm just looking at it like I don't.
Yeah, I can't remember all the stuff.
So.
this is an expression, just like a string is an expression or an array is an expression. It's like a value, a number. It's like a thing that has a value, or something like a statement, or something maybe like this variable declaration. This whole thing here doesn't have a value. Like you couldn't set a variable declaration equal to a variable. Like you couldn't do something like this.
Okay.
Like this thing doesn't really have a value, where like this thing, this string, does have a value.
And that's why you can set it equal to something.
Exactly. Yeah. So that's this sort of concept is called an expression, versus where this is called a statement usually. There's usually the words used. So this is an expression, just like a literal array, like something like that is an expression, just like a variable like A is an expression. Either way, any sort of expression you could put in for each, or you can pass like a function, or it doesn't matter. It can be anything. It's part of the power of programming languages. It's sort of like that you can put anything in the expression-shaped hole, and a bunch of things fit that expression-shaped hole.
That's wild. All right, cool.
So, given that,
I can actually just iterate over that such thing.
yeah,
I can just call that a
Oh,
free.
this-
I usually like it's a placeholder for iteration, like index or I. It's like iterate. Programmers are lazy.
Right.
Yeah.
Programmer. Okay, so just saying, I console log.
Yeah, give it a try. Give it a try.
Okay. I don't know if this works, but we're gonna see what happens if they do.
Cool.
Are you giving it here? No? Excellent.
Okay. Now the one thing I'm going to say,
Yeah, go for it.
I'm going to get rid of this console log around here. So it's not going to cause me problems. It's going to make me less. Do that. Oh, we do. Yikes. Okay. Over here.
Oh my God, computer magic.
Computer magic.
Excellent.
Yeah. Now you've got, you're logging at each entry in that. So now somehow you gotta extract things from this. Like you gotta get like the author or the publisher or the title or whatever you want to put on your page, up to you. So you know how to do that.
There's an AC thing.
We did once and we will again. But at this particular moment.
You've got access to I. And each of these I is each entry in this array.
I mean, isn't it like title, author, image? You can put like title, is it like title, author, image? Because that's part of the.
So there's two syntaxes to do this. Either something like dot, so you
do like.
Yeah, like, oh my God, no.
It's
Okay,
totally
oh my
fine.
goodness.
No, it's totally fine. Totally fine.
Yeah.
Or you can do a brackets title. Either of those are the same. Do a key lookup like that.
Good old dot notation.
Good old dots.
Good old dot.
Yeah.
Okay, so I could just call like I dot title or I dot.
Yep.
What's the change?
What's the key in here? Book image.
Okay, so I could call it that.
Can do that. So once you have that,
Yeah.
once you're logging in all those things, you're logging a bunch of text. Now you have to do something where in your loop, you've got to create like a P element, and you have to add that text into the P element and append it to the body. And you just
Right.
loop over that over and over, and then
Okay.
you're going to have like the in your body. So it sounds like you can figure it out. You can figure it out, but
Okay. Can I do that in that same for each, or do I need to create a collective?
you do it the same for each. You could if you wanted to. You could turn this for each into a map. And you could return each of those and then loop through it again in another like for each or map and add them to the body.
Okay.
That's not unheard of. But if you want to do it in one, that's fine too. Whatever's easiest. Yeah. Because map returns, this is a good lesson, because map returns an expression, it returns an array. You can chain maps. You can have an array dot map dot map dot map infinitely.
Wow, all right, cool.
Yeah.
I think I can make this now. Okay,
Yeah.
fun.
Cool. Okay. It's funny how I haven't made a full evolution of the room yet.
Because I kind of got that, but I don't know what to
I think beautiful.
Oh,
I'm either messing
Yeah,
with my
nice. Whoa, Ask Gary B as a book that's like
I'm not-
doing well.
I'm
Wow.
not.
So
Gary B
anyway,
is an interesting dude.
Yeah.
if I did like this,
Cool, yeah, that totally works.
success.
Okay, so,
The only thing I'm having trouble with now is like, all right, there's no space between. So how do you address that?
well, so how would you, if you had two DOM nodes, how would you do that? Like if you were writing HTML.
Yeah,
how would
take
you
out the
address that problem?
response status because you're showing it 200. Yeah, so we can.
No, but I need like, yeah, I don't know.
If you put them in elements, you could do something like just give margin left to one or give margin right to the
I
other.
mean, I get it, but I don't get it. Like,
So-
he was just saying.
Although,
I feel like I'm just.
those are empty. Because there's only one key element. These are just text nodes that are inside the scene.
Yeah.
Like if I,
So what if you make those
like if I
elements
look at
instead?
this, yeah, I can just
Yeah.
this.
Yeah, exactly. So what if you made that key a div, and you made two P's inside of the div?
So. Kelly,
Okay.
where did you
Also-
put that to get the response question?
So when you're,
Where I was just watching.
when you're doing it like this, it's not gonna show up in your actual HTML. Is there a way to make it show up or no?
No.
Okay.
So if you're making stuff dynamically in JavaScript, it's dynamic.
It's, right, so it's not meant to be static like that.
Yeah, it's not static, like you can't put it in the HTML in your file because it has patches.
Oh, right, because every time it goes, it's executing it.
Yeah.
Got it, okay.
However, DevTools will show you, because that's like show you the real-time
What's
representation.
actually there right now.
Yeah.
Okay. All right, I'm gonna mess around with it now. I have like at least a title and an author.
Yeah, I mean, this, what you did there, that's what I would say that's like, that's the assignment, that's really what I want.
Okay.
So anything extra you can do here, yeah, have fun, make it look pretty, yeah,
Okay.
you're good.
Cool.
Like, I think Kate and I are in a similar place. Yeah, I don't know where to put what you just did with Kelly, which I kind of understood, but don't know how to duplicate.
Yeah, okay, so you've gotten data, which is some JSON, you're logging that out, which is there, okay, cool. You got this here. So what you want to do is you want to get that books array, which is in results and books. Just like with Kelly, you need to get that books array. So you need to like descend into this object. You need to get find the thing that has the key results, the thing it maps to, the thing that books, and the thing it maps to.
Okay.
And then once you have that array, then you can loop through it in some way. You can use for each, use a for loop. Looks like you used a for loop. Use a for loop and get through it. And then once at that point, you
once you loop through that, I would say start with just log out everything that you get through.
So is that data or info? Like, I'm not clear here. Where's like Kate and I were just saying we're just.
Oh,
putting stuff in. So.
Yeah, so the thing you're logging out, this variable here, that's data.
Okay.
Info, I would say just let's comment out info for now.
Okay.
It's not, we're not quite there yet.
Okay.
I'd say for now, start with log out just this array. Don't log out this whole JSON object, just log out this array.
Okay, so that would be back to here, so it would be data dot.
No, not quite a map. So data is an object. You need to get, can you go back to your browser for a second? You need to extract the results key and extract the books key. And then once you do that, this books key maps this array. Or that's what that what the value is of that key. So if you can get what's in results and what's in books, you'll log out this array. So can you get
No.
can you get what's inside of results? Maybe you know place to start. Can you get what's inside of results? Yeah. Yeah. So log that out. Yeah. Oh, that's the results portion. So you see the whole thing there, and you see the results. You log both of them out. But now, click on that guy, open that, this is the results one. Or go there, I guess, yeah. So open that up. So now you need to get the books key inside of there.
Okay.
So how do you do that? Modify that one. Yeah. You got an array of books.
Oh, so now I can just do the array dot map dot for each or array
Yeah.
dot prototype for each?
Just array dot for each, but you need to loop through it somehow. For each is one way to loop through it.
Okay. All right, now I have an array.
You can put it into a variable. That might be a good thing to do.
So that would be.
Yeah. I think you're on the right track.
Since I've been pouring it on everything.
I'm gonna help you.
Well, first, everybody else said that books I don't have, so I think I have to be somewhere where I shouldn't be. I'm guessing that this here is wrong.
So what's in that guy? Open that up. Go to results. Oh, lists. Yeah, okay, so you're getting back to a little different. Yeah.
So something happened. That's one issue.
No, I didn't get it resolved,
Okay. So yeah, I would guess you're probably making the request to the wrong endpoint. You're getting back
what
to
I'm
the
doing
endpoint.
right
And like,
now.
to be honest, I don't really care what endpoint you request. Really, the exercise is make a request, get data, render to the screen. And if that data is books, if it's something else,
And-
okay. But
Yeah, we can't.
it sounds like you want to use the right data.
Well,
So-
yeah, especially because it,
And when I used to help the students, like, it's literally I used to shop your sign.
oh,
Oh,
eventually
yes.
it's the books, but then
Yeah.
there's like,
You put your books.
Yeah.
Right, but this is a free version of it. Inspiration is probably actual where we use that.
So
And
Kelly, did you define I?
yeah, that's interesting.
this is,
So
I
I,
don't know if you want to take a look at it.
Well, I'm kind of using I as like a placeholder variable.
Yeah, so we just really look at actually.
Yeah, you got
So what they do is to get started.
So moving backwards.
Right.
What I got back when I was doing this, we were saying that you've got everyone else.
Here's the
So
I
I would say
And I'll go with.
the process to render each list is going to be pretty much the exact same as rendering here instead of writing book.
So here is
So
okay, your central
just
topic.
because he's working right now,
So you
I'm
double
gonna say let's do it with this endpoint.
Okay.
And then maybe if I look at someone else's computer, see what they're requesting and see if it's the same thing you're requesting.
And then.
Maybe you're doing it right and everyone else is screwing up. So that's what I'm trying to say. Which would be fine, like still accomplishes the goal, but so
Provider location.
gotta wait here.
Provider destination.
Cool, okay. So we got this. So
It helps you plan,
we need to
you know.
move through list this
So
list already.
let's say.
So the first step is you need to
You
get
did
the list
some of
already
that.
before
I understood on that.
to
So
extract
go
that out.
ahead, I
So
can
maybe a good
extract
place to
it,
start even there is just
Right.
logging out that
and
list.
then I'll start here at the source and I can create the relationship. And now when I move this, the arrow will follow it no matter where I put it. So I can begin to like
no, but,
arrange this in a
if
way
you-
that seems logical for
You have
me.
results output. So when you see,
I
sorry,
need
it's
to
going that way.
do
I'm used to having my thing over here, so I'm just gonna keep doing it.
this.
But
So
we
now
have
I can
this
move
variable,
and
this
and then-
being logged out here is results
I can
output.
change the colors of these. I can
Results
change
output is an
the
object. It has a bunch of keys that map to a bunch of values.
Okay.
And it has, so it has a bunch of keys there, so it has
So like
status,
that's
it has
actually
results,
stuff that
and
I
that
want to
goes to the
add.
top right.
Instead of adding it
Inside of
to a shuffle board. So,
Yeah.
say I can
Yeah,
create
yeah.
yeah, I can create another subtopic, right? Create my relationship to that. But then if I wanted like another topic off of that,
Oh, there we go.
pick
You got it
subtopic,
right.
or
I'm gonna loop that array, do something. with
return,
each
return,
item.
return, I
How-
get that.
What's your favorite way to loop? Okay, you have a
Yeah,
you got it.
yeah.
Okay. So you're looping to 5
Yeah,
times.
it is.
Really, you want to
And I
loop
knew that it
each
was
item in
out
that
there,
array.
you know, just once again, if I want to start
You want to
creating
plan it.
relationships
So
between
you're
these three
for looping,
things.
you're starting
See,
here.
I'm like, where
Going
am
to
I?
five.
Okay.
No,
So I'm like, this is so. Go back to
That's a really
that.
good idea.
You could do, I mean, top 5 is perfectly fine.
And then you can get
And then
other
so
stuff too.
if you have the
Yeah,
index of an item in the array, how do you get the item the index is mapped to?
So-
If you have 0, how do you get the
Right.
item topic? If you have 1, how do you get the item? How do you get this little one there?
This is called
Yeah, exactly. So we have an index I. How do we turn that index into an item?
And then-
Fraction.
Yeah.
So I'm gonna say, inside of this loop, log out every single item of the array, like from the first item, the second item, third item, fourth item, all the way
Yeah,
up to the
X,
end.
Y, and Z.
Are you, yeah, comment that out.
Slack?
Yeah.
Okay, why do you have to give me your name? Oh, that first. I can do it, I know it.
I can do that.
Yeah, it goes there.
And then it's really cheap.
It's-
This is a free trial.
So what's,
It doesn't
what
say
is
that,
the array?
it doesn't
What
say.
is the array you wanna get the index?
So I'm thinking it's another trial. This way,
Yeah,
you gotta pick, you want more features.
Exactly, yep. So then this here, this expression means the array. Same inside of console.log. So if you wanna get to the index inside of that expression, you need to have that whole expression there. Yeah, so there we go, we got 5 lists being logged out. Okay. Now we have that, we have most, like, you got the rest of it pretty much here, like, you're, if you uncomment the stuff that you commented out before. So you're now, this, I put this, yeah.
I might have been close, but I was like, I'm definitely. Oh, that's it.
Yeah. Try that. Object. Just talked about that.
Define
Well, so why is an object? Well, you're looking out. You're looking at your terminal. Logging at the console, I should have recognized this and steering you in the direction. You were logging out a whole object.
Yeah.
Have you guys entries? You need to actually log out something like,
nobody said I could.
maybe like
That I
list
saw
name
it, yeah.
would be a good place, maybe something to log out. So if you have an object, how do you get the value the list name key maps to?
Yeah, not donation.
It's not, they do have something similar.
Now, here's the thing. What you're doing here is just you're saying this object gets the key results, get the key lists, get the key list name, and then the value list name matched to get the
Say, I'm sorry.
item tree effect. That's not quite what you want to do.
Oh, I just.
If you wanna look at,
Yes. But the, actually, let's run this. Let's see what this does. I'm not exactly sure what this is going to do. Maybe it's just going to do nothing.
See, I'm looking at
Okay,
this.
here, so you can see what a
Variable in.
Right, yeah.
Yeah. So for each doesn't it for any or okay.
Get rid of the extra thing you had added. No, get rid of the list name bit. So just get it back to what it was before. Oh wait, and comment this stuff out again. Sorry. So we're back to where we were before.
Yeah.
Each of those is an object. So if you have an object, how do you get key? How do you get a key with an object? It's not notation. But what's the object? This whole expression here is the object. So like you could do something like say var a is equal to this, and then a would be equal to the object. So like it's if you want to do something with this object, you have to put it at the end of all this. Because this here is the expression itself. So like maybe break it down a little further. Results output. You want to do something with results output. You want to get the results key, so you put it after results output.
You don't
want
have
to
to
get the
put
list
index
key
for
of
each,
results output dot results.
iterators
So this is the expression, and you've got this key out of that expression. You want to get the array entry out of results out of this expression.
So
that after
I've got the
this
data
useful
that
expression
results
here.
out
This
books.
whole thing here applies to
That
everything
would
before.
be
Like
a
an object, if you put parentheses around this, it's like this. Is that helpful?
Okay, so I get this object.
Yes.
I'm still trying to figure out how to do this.
Okay. So if,
Do I have to
oh,
assign an I to something? So
Yeah.
it's iterating through results output, results.
no, so you're
Iterating
iterating.
through the list, but then take.
You might have roughly the right idea, but you're not.
Do it.
You're iterating correctly.
I want to see
You're locking out the object. I think I'm gonna write out the answer, and I think you're gonna say, oh, I know this. Yeah. What to do is something like this. It's got applied the list before it. So when you were putting it here, what you were doing is you like it's an array, right? So that's not gonna work. That makes sense.
Yeah.
Okay. So go back over here. Oh, sorry. Go back. Where is it? Here. It moved. Go back over here. Now we get logged out of the strings. So I'm gonna leave as an exercise for you. Take this, plug it into here, and get this to work. Get very close.
15 books, yeah, I want to make work.
Thanks.
Yep.
Of the title author.
How you doing? Okay. Want me to take a look? Okay, yeah. Yeah, yep. That's the way you're supposed to do it. I didn't quite get that part. Maybe I should talk about promises. Yes, this works totally fine. I mean, yeah, you're on your way. Like, if you have anything in particular you want to ask me questions about, you're welcome to. But yeah.
minorities, yeah, but you're doing a good job. You're doing fine.
No.
Nice work.
It's all good.
Saw Katie was helping me earlier.
Yeah. I had the wrong. No,
Still an issue there, though.
No, it's new stuff.
Restyle.
Yeah, I can't just add dot author.
I had the
So
wrong,
if you want to get a.
Document, yeah.
Okay.
You did it.
The download.
Oh, the wrong,
so shit, this year, and I'm trying to figure out.
It should be array of looks.
So you have to do everything.
You could do, maybe.
yeah. Wild, fun. It was a while.
You want each item to
Yeah.
be like.
So,
Author or
I
whatever.
had the list.
Scroll down. Let me see this list. Oh, and here you have the list.
Yeah.
Okay, so you gotta put it in the DOM.
Yeah.
You know how you can accomplish that?
Yeah, I did it before.
Okay.
And she said, hey, if you want to. So, no.
Oh, okay, cool. So you're on your way. I'm not gonna interrupt you anymore.
Why is this
Cool.
Your line
So
after.
I switched gears because as you were talking, I
Oh, I
started thinking, that I don't
So you
really
like
travel, organizing my project and I would.
So I can't just make this book's not titled on
Tell my students to use a mind mapping
Are you doing
flowchart
that?
program called Inspiration. Okay, inspiration is really nice.
We define the function.
You have to go for it.
Right,
And
so
so I
it's
was
the
looking for,
Um,
free version.
Right.
Something that becomes similar
Title, author.
that I don't have to pay for. And
So I don't
think that I really.
No, so,
Google has something
yeah,
called
I can
drawing
do that
control.
there.
Okay.
You probably. What I like about that is that I actually found a template that allows me to, expand and collapse each topic. So I can have like my main topic, maybe a few subtopics, and then I can expand and collapse as I need to see different things because the project is going to get really complicated. This is going to help me to focus on the different pieces of it.
Yeah. Okay.
So, so that's what I've been doing.
Oh, no, that's fine. Okay, so, so this is kind of the
So,
ten elements that you're
I'm
making.
gonna give it to the
you're
project
calling
that you
your
wanted us to do. Is it, are you gonna post it?
It's a Google
You create a
Classroom.
new paragraph.
Yeah.
And then
So
you
it's,
fix your
I made the assignment on Google Classroom. I
Okay.
posted it on there. Like, I include the link to it, but I just should have done.
So I should just make it
So it's not.
No, it's, you're gonna be able to find it in Slack. Or
Slack.
click on it. Maybe they did include it. I don't remember. No, I didn't. Yeah, I'll put it in there for later on, but it's in Slack, or if you go to that careers and code, classroom code base repository in GitHub.
Oh,
You'll find the file.
Okay, so you
I
want
want
to
to do
do
the same thing
because I'm
for.
so used to trying to find stuff.
Yeah.
Okay,
I'm
but,
really bad
but
at
you
it.
did, yeah. I thought Chelsea gave everybody, all the instructors access to it. Maybe William was the one putting the stuff up. I don't
Oh, no, no. So what's your object, right?
know. So this
Yeah.
is-
Access to what? To Google
That's
Classroom?
the field,
Yeah, so that you can, put
author.
the links to the assignments.
Yeah. Oh, I have access to it. I just am really bad at remembering it.
So
Oh,
inner
okay.
HTML.
So,
I can, yeah, I can update that assignment. I'll do it a second update if
All
you
right.
want, but.
but in the meantime, I just go in here.
Yeah.
I don't know whether that you write it that way, but you can.
If you scroll up to like yesterday, you should be able to find it.
To the back there.
Go further higher. Past Karen, past Anna. Yeah, that one right there. Yeah. It's in this module 5 folder in the careers and code classroom code base Git repository. This has all the exercises. It also, if you're curious.
Yeah, when I get to
All of them,
the
I think
end,
the one from last
but
night,
how
the
am
one for
I?
today is the- Yeah.
So do I
So
just
the one
keep telling
for today is
info,
the-
Final exercise, yeah.
You
That's
can
what
do
we
it
worked
on
on
one day if
yesterday.
you want to do it in.
It's just continuing that.
Yeah, dot author, dot, okay.
I finished this.
Oh, you did? You got it rendering to the web page too?
No,
Okay.
I didn't finish that part.
Yeah, that's the part you got it. That's what everyone else is working on.
Cannot read.
So-
I'll go ahead and continue.
There's that, yeah.
Yeah, so your advice to me yesterday was, it actually wasn't about the language. I was trying to get each of my responses to have a line break in between from everything that was being returned from the server.
Yep.
And I hadn't quite figured
Yeah.
that out. So what I'll do is I'll work on the web project and then I'll get my.
Yeah, I mean, I would say, it's not like, if you don't get it done, it's totally fine, it's more just, I feel like it's a sort of project where it's a great thing to have on your resume. It's especially where you are right now, like it proves you can tie a bunch of different things together. So, just for the
So
game,
I'm thinking
I'm
that
facilitating, it
you're
would be
saying-
helpful.
And then,
Yep.
Okay.
Are you gonna go through it?
Through what?
The New York Times thing or no?
I wasn't planning on it, but I could maybe. I don't know. I kind of want to let people come to their own conclusions to some degree.
Turn it in tomorrow, is that
Yeah, turn it in whenever. Like,
okay? Okay.
turn it in before the class ends in August. Like-
Fair enough, I think I can handle that.
Yeah, no rush.
Okay.
I need to grade a bunch of stuff anyway, so.
Yeah, well, we were trying to do
Okay.
that. We were trying.
I'm gonna stop the share.
Jeff